This is a sphere. A sphere is a perfectly symmetrical three-dimensional geometric shape because every point on the surface is equidistant from a central point called the center. It's also called symmetrical because whichever you cut here, you will come up as long as it passes through the center. It will automatically divides this solid into two symmetrical shapes. Now, a sphere has no edges nor vertices. And the key concepts that we're going to use here for a sphere is, of course, since if we're going to cut this symmetrically passing through the center, you will come up with a circular, just like this, a circular face here. So we are going to use here the concepts of the circle, such as radius and diameter. The diameter is, of course, the distance from one point to the other passing through the center, and the radius is half of that. In this video, we are going to discover the secret in the formula for the volume of the sphere. We already have the formula for that, but we are going to discover that here this time. Now, to understand the formula for the volume of the sphere, let me reintroduce to you this solid, cone, and cylinder, and they have the same circular base as each other. Circular base, and the center, again, as mentioned, if this is cut through passing through the center, the circular shape is the same as the size of these bases. Now, here is what will happen in this illustration. First, let me try to fill, I'm going to remove this so that my sphere will not run. Okay, no worries. Again, it should be closed, but I'm just going to do it like that. Let me fill this cylinder completely with water. Okay. Assuming that I have completely filled this up. Now, in the understanding of the formula for the volume of the cone, we have established that the volume of the cone is just 1/3 of this volume of the cylinder having the circular base. So if I'm going to fill this up, okay, hopefully nothing will be missed here. Okay, all right. Okay, completely. This is the volume of the cone, and it's just 1/3 of this. In short, what remains in our cylinder is just 2/3 of the volume of this cylinder. Now, looking into that, let me transfer this water here on our sphere, and you will see a very good illustration on the relationship of this cylinder and the sphere of the same circular base. Hopefully, I could do this properly. Alright, now, as you can see, the remaining water in the volume of in the cylinder completely fills up the sphere here. And what can this tell us? As mentioned, the volume of this cone is just 1/3 of the volume of the cylinder, hence the remaining amount here is 2/3. So, the formula for the volume of the sphere is just 2/3 of the volume of this cylinder. And the volume of the cylinder is given as pi r squared h. So the volume of the sphere is 2/3 of pi r squared h. Let me continue this understanding here. Again, we have established that 2/3 of pi r squared h. However, for a sphere, there's no height here. Because if we're going to look into the formula 2/3 of pi r squared h, yes, we can solve for the radius, but, or there is a radius here, but the height is not observable. So let us try to look into the concept of the height. The height here means the distance from one point to the other point which passes through the center. Earlier, we have established that that is just the same as the diameter of the circle here. The diameter of the circle, that is actually our height. And what is actually diameter in terms of radius? We know that the diameter is just twice radius. In short, the 2/3 pi r squared h, the h there, can be changed into the diameter, d, or can be represented by 2r because the height is the diameter and the diameter is 2r. Now looking into that, we now have 2/3 pi r squared times 2r. Simplifying that, we will have this illustration. Of course, multiplying 2 and 2, you will get 4. And there are 3 r's now. That is why the final formula for the volume of a sphere, looking into its relationship from the cylinder, taken out with a relationship of the cone, is just equal to 4/3 pi r cubed. This is the secret in the formula for the volume of any sphere.